Imagine you are sitting on a small observation ship just above Earth, looking down at the blue glow of our home. In the sky, the Milky Way is just a pale band of light. Tonight, that changes. Because we are about to leave the solar system and travel all the way to the monster waiting at the center of our galaxy, the supermassive black hole called Sagittarius A star. First, we fire the engines and climb out of Earth's orbit. The moon falls behind. The familiar blue of our planet shrinks to a bright marble, and the sun takes over the sky, glaring like a white gold furnace. You can still pick out the orbits of the other planets as faint rings of dust and rock, but very quickly the details fade. Mars, Jupiter, Saturn, all the places that once felt so far away are now just tiny dots huddled close to the sun. As we accelerate, we cross the outskirts of the solar system. We drift through the Oort cloud, a vast sphere of icy bodies and frozen comets that surrounds our star like a faint invisible shell. Here, sunlight is so weak it is almost meaningless. The sun, which once filled our entire daytime sky, is nothing more than a slightly brighter star among many. Now pause and look back. From this distance, the solar system is not the center of anything. It is just a tiny island of light in a sea of darkness. Ahead of us, that darkness is filled with something bigger, the Milky Way itself. From inside it, our galaxy is hard to understand. It feels like a sky full of random stars. But as we continue to move out, patterns begin to form. The stars are not scattered. They belong to a gigantic, rotating disk. We are leaving one small neighborhood on one spiral arm and heading toward the crowded, dangerous downtown at the very core. Our ship now settles into a cruise speed, gliding along one of the Milky Way's spiral arms. This is the Orion Arm, the galactic suburb where the sun lives. From here, the galaxy is no longer just a backdrop. It is a landscape. On either side of our path, enormous clouds of gas and dust stretch for light years. Some glow pink and red, where young, massive stars are lighting them up from within. Others are dark, cold lanes of dust that block the starlight behind them like cosmic storm clouds. These are stellar nurseries, places where gravity slowly squeezes gas into new suns. As we weave between these clouds, we pass bright, open clusters of newly born stars, hot, blue, and short-lived. Further out, we glimpse older, redder stars that are reaching the end of their lives. Everywhere we look, there is motion. Stars orbiting the galactic center, gas drifting, shock fronts rippling through nebulae. The Milky Way is not a static picture. It is a slow, swirling, living system. The distances are almost impossible to grasp. Even at an absurd imaginary speed, it takes us tens of thousands of years of travel time to cross from one part of this spiral arm to another. While we glide forward in our simulation, entire civilizations on Earth could rise and fall. Eventually, we start to gain some perspective. We pull our camera view out wider and wider until the arm we have been following reveals its shape. A curved, luminous lane, one of several wrapped around the galaxy's core. From this vantage point, the sun is just one faint point lost on that arm. Now, our course is clear. Instead of circling the galaxy like most of its stars, we are about to cut inward, toward the brilliant, crowded center. Ahead of us lies the galactic bulge, a swollen, glowing hub of stars where gravity, radiation, and density all ramp up. Compared to the calm suburbs we are leaving behind, The downtown of the Milky Way is something else entirely. As we dive inward, the number of stars around us begins to rise dramatically. What used to be pinpoints separated by vast darkness now starts to look like a dense city of lights. This is the galactic bulge, the central swelling at the heart of the Milky Way. Here, the night sky would never be dark. If you could stand on a hypothetical planet in this region, the sky would be packed with suns. Many of them would appear brighter than the full moon does from Earth. The concept of night would barely exist. Our ship threads its way through this crowd. We see stars whipping past at higher orbital speeds, pulled by the intense gravity of the galactic center. Great clouds of hot gas glow in X-rays and ultraviolet, marking regions where energy is being violently pumped into the environment. Sometimes we pass near tight clusters of stars so dense that in a sphere only a few light years across, there are thousands of suns. The closer we get to the exact center, the stranger the motions become. Some stars follow long, stretched-out paths, diving in toward an invisible point and then slingshotting away. Others trace tiny, fast loops, completing full orbits in just a few years. By tracking those orbits, astronomers in the real world have measured something remarkable. All of these stars are responding to a single, compact, incredibly massive object that we cannot see directly. Even without looking at it yet, we can already feel its presence. The mathematics of their orbits point to a mass about 4 million times that of our Sun, squeezed into a region smaller than our solar system. No ordinary star can do that. No cluster of stars can do that. The only thing that fits the data is a supermassive black hole. We steer the ship along the same paths those real stars follow, curving closer and closer to the invisible anchor they are all orbiting. The lights of the bulge surround us, but ahead, in the very center of this brilliance, there is a place where light itself begins to fail. Now, at last, we approach the monster itself. The star field around us stretches and warps in strange ways. Light from behind the central object is bent into arcs and rings, wrapping around the dark circle in the middle of our view. We are finally close enough to see the distorted outline of the supermassive black hole Sagittarius A star. Of course, the black hole itself does not glow. What we see is the chaos around it. Gas and dust that have fallen toward the center form a hot, swirling accretion disk, spinning at a significant fraction of the speed of light. Some parts of the disk appear brighter than others because of relativity. Light coming toward us is boosted, light moving away is dimmed. The result is an asymmetric, lopsided halo of fire wrapped around the perfectly black shadow. We hold position at a safe, imaginary distance. Even from here, the scale is hard to comprehend. This single object outweighs millions of stars like the Sun. Any star or cloud that wanders too close can be stretched, squeezed, heated, and eventually shredded, feeding the disk and lighting up the surroundings for a little while before disappearing forever. It might be tempting to imagine diving in, crossing the point of no return, and seeing what lies on the other side. But from the outside, the story ends here. Once something passes the event horizon, no signal can come back out to tell us what happened. For us, the edge of the black hole is a curtain that never lifts. So we simply watch. We watch the nearby stars race along their tight orbits, slingshotting around this invisible anchor. We watch the glowing disk flicker and swirl. And we remember that all the way out on one of those distant spiral arms, there is a small star with a few rocky planets, one of which happens to host the beings who figured all of this out. Our journey from the solar system to Sagittarius A star is over, but the story of black holes is just getting started. In the next episode, we will ask an even stranger question. If you could orbit a black hole safely, could you watch the future of the universe unfold in fast forward before your eyes?